Good morning, good afternoon, good evening. Welcome back to Chapter 1. Let's talk about the process of science. Let's talk about how scientists figure things out. There are several steps to the process of science. The process of science is based on inquiry. The process of science is based on asking questions. We want to figure out how the world works. We want to figure out how nature works. So the first step, we observe. We observe a natural phenomenon. Example, we already talked about what happens to the leaves in October. They change colors. That's a natural phenomenon. I observe that leaves change colors. Next is you have to ask a question. Why do the leaves change colors? Let's ask a better question. When we say, why do the leaves change colors, we're probably really asking, how does the tree know it's time for the leaves to change colors? That's a better question. I observe that leaves change colors. How does the tree know it's October? How does the tree know it's time to drop the leaves? All right, now I have to make a guess, and that's a hypothesis. But what else happens in October? What happens to the weather in October? Oh, October is when it's finally not hot anymore. It finally starts to cool down. Is it reasonable that a tree could detect temperature? Maybe, I guess. Let's find out. I guess it is the change in temperature that leads the tree to know it is time to drop the leaves. It tells the tree that winter is coming. Winter is coming. It's telling the tree winter is coming and it's time to drop the leaves. Now I make a prediction. If it is temperature that tells trees it's time to drop their leaves, then if I control the temperature around a tree, I can make it drop its leaves. A prediction is an if-then statement. If I control the temperature around a tree, then I can make it drop its leaves. Well, my guess led me to my prediction. My prediction leads me to my experiment. So what kind of experiment should I set up to figure this out? Well, let's put a bunch of trees in a greenhouse with a big air conditioner attached to it, and let's drop the temperature and see if we make trees drop their leaves. Yes. Let's make a better experiment. Let's have two greenhouses. One that we're going to allow to be the same temperature as it is outside. The other one that I'm going to control the temperature of. And these two groups, my first group that I'm not going to change things is called the control. These two groups are going to have all the same conditions. They're going to get the same amount of sunlight. They're going to get the same amount of water. They're going to get the same fertilizer, the same plant food. They're going to get all the same everything. Except my experimental group, I'm going to drop the temperature by 1 degree a day. Dropping temperature by 1 degree a day, is that a lot? No, that's not a lot. I mean, we have some days where it's like, 75 one day and then 80 the next day. That's a 5 degree temperature change. So 1 degree a day is not a big temperature change. We're going to start the process in May, and we're going to drop it by 1 degree a day. Well, what's the temperature like in May? Temperatures in May are 85, 90? Let's pick 90. We're going to drop it by 1 degree a day. What is the temperature like in October? October is probably back down to about 85. Okay. So we're going to start at 90 degrees. And we're going to drop it by 1 degree a day. October, how cold does it get at night? October at night you get down into 40s maybe. So maybe that's what it is. Maybe it's that nighttime temperature that it tells it. 85 is one thing, but 40 is a bigger deal. Okay. May 1st, we're going to start at 90 degrees. Every day, we're going to drop the temperature by 1 degree in our experimental group, and the other group we're going to allow to stay the same. Whatever the temperature is outside, we're going to let it be that temperature. We're not doing anything to it aside from putting the trees in a greenhouse. Should we just have one tree in each greenhouse? Or should we have like lots of them? Does it have to be like a whole big full-grown oak tree? Or can it be like, like a 10-foot sapling in a pot? They drop their leaves too, right? Well, yeah. So let's put like 20 or 50 trees in each greenhouse. So we have more than one experimental subject. If you just have one, that one could be weird. And that one could be sensitive. If I got 50, well, then I have a lot of different ones. And I have a bunch of them, and then we should get the right average. All right, so we're going to drop temperature by 1 degree a day. By the end of May 31st, I've dropped it now by 31 degrees. I started at 90 degrees. Now my temperature is at 59. Okay, we'll start out at the 40 degree mark, right? So now we're going to let it go all of June. If I start at 59 and I start dropping it by 1 degree a day, somewhere towards the end of June, I'm hitting that 40 degree mark. 19 days, June 19th. I've hit that 40 degree mark. So I should be seeing the leaves changing color. They should already have started changing colors by now. And what has happened? Have they changed their leaves? And the answer is no, they didn't change their leaves. It wasn't until I get down to actually freezing where I froze the leaves off and killed them that they finally dropped their leaves. Well, rats. Our experiment was a failure. We didn't learn anything. It was a waste of time. Was it a failure? Did we learn nothing? Well, I mean, we learned that temperature isn't it. Yep. We learned something we didn't know. Temperature is not what makes trees drop their leaves. It's actually the amount of daylight. Trees time the night. What's also happening in October? The days are getting shorter. That's how the tree knows. They don't care about temperature so much. They care about how long it's daylight. We said that a hypothesis is a guess. If you watch modern shows and they talk about a theory, modern murder mysteries or police procedural dramas or even medical procedural dramas, and it's like, the main character says, I have a theory as to who the murderer is or what the disease is or whatever. I have a theory. Is his theory proof? Has it been proven, or is it just a guess? And the answer is his theory is just a guess. That is not a scientific theory. That is a hypothesis. A guess is a hypothesis. A theory has been tested many times, many ways, by many different people over many years, and has not yet been proven false. That's what a scientific theory is. Gravity is only a theory. Well, fine. If you don't believe that a theory is right, then go ahead and jump off of a building and tell me that you don't believe in gravity, because it's only a theory. It doesn't matter if you believe in it or not. You're still going to go splat when you hit the ground. A theory is not a guess. A theory has been tested many times, many ways, by many people over many years, and has not yet been proven false. When we talked about our greenhouse experiment, we didn't just have the experimental group. We also had this idea of a control group. And the control group is the group that you want to compare your experimental group against. Who knows? Maybe there was something in the water that would make the trees react weird. Maybe there was something in the fertilizer that I used. Maybe there was something simply by it being in the greenhouse that made the trees react weird. I need to know if anything I did besides the temperature change is going to impact the trees. And so therefore, that's why I had that second greenhouse, the control group. You always want to have two groups. You have the control group and the experimental group.